as the title suggests, we're going to talk about 3 free Python tools that you can use to bolster your defense and incident response capabilities. So my name is Mark Baggett. I am, there's a little bit of information about me. I do penetration testing and incident response consulting. I also work primarily these days with the Department of Defense and a long-term contract working with those guys in developing their capabilities. I am a senior instructor for the SANS Institute, and I'm the author of SANS SEC573, which is Automating Information Security with Python, a course that's designed to teach you how to code and how to develop scripts and tools to automate the mundane in your life and make you a more productive information security professional. I do have my master's degree and GSE number 15. I'm going to claim GSE number 13 because that's Eric Conrad's GSE number, and I've always actually wanted to be Eric Conrad. So I'm GSE number 13 for the day, and I've got 18 years of commercial experience was a CISO for several years. Although I've never contributed to the Metasploit framework directly, I have come up with various techniques and tools for doing offensive and defensive and forensics type capabilities, such as my name does appear in the source code for Metasploit a couple of times, even though I haven't directly contributed a tool. Okay. So today's topic is how to develop tools in Python that can solve your information security needs. We're going to talk specifically about 3 tools that I've developed over the years and continue to maintain, and how you can use these to identify attackers on your network and identify what attackers have done in an instant response. If you're interested in this topic and you want to build your own tools or modify existing tools to better meet the needs of your organization, let me just point out a couple of opportunities for taking 573 in the near future. At SANSfire in DC on July 16th, I'll be teaching there, and that class is coming up very shortly. So today's a great day to sign up for that training opportunity. We also I'll be teaching at Network Security in Vegas on September 24th. Both the SANSfire and the network security classes are going to be simulcast on the web, so you can attend remotely, even if you can't make it to those destinations. And Joff Dyer is going to be teaching at Pen Test Berlin in Germany as well in just a few weeks. So if you're in Europe, that's a great opportunity to come and take the class there as well. And it's also available on demand if you're interested in that. But today we're going to be talking about 3 different tools that you can use to do your defense. Let me give you a quick overview of what's in the course. I'm sorry. Today, and in the course, the first 2 days are focused on building the essential skills that you need to develop any application or to modify any application in Python. So we assume no knowledge coming into the class of coding, and we will start from scratch teaching you everything that you need to know in building Python apps. The course focuses on teaching you Python 3, but we have an eye towards compatibility with Python 2 and writing tools that will work in both Python 2 and 3. As a matter of fact, all of the tools that we'll be talking about today are cross-platform. You could run them in Python 2 or in Python 3. So we'll talk about the issues with that and how you can make your tool work across both platforms to reach the largest audience in the course. Once we've talked about the essentials, then we start focusing on coding projects to meet your needs in information security. Each of the different days that follow that have a particular focus. So day 3 has got a defensive focused apps where we talk about reading file systems, looking through logs, identifying attackers through various techniques in our log files, in our packet captures. Day 4 is a forensics-based day where we talk about analyzing binary files, pulling out the different pieces of those from our forensics capability, to find forensics artifacts on our systems. And day 5 is offensive focused. Now, even though the projects of these have a theme, the concepts that you'll learn throughout the course are things that are universal to everyone. So, for example, on defensive day, we talk about opening files and regular expressions. And that's certainly a topic that you need whether you're forensics or offense. There's also a capture the flag or a coding event that happens on day 6 where we have a challenge for everyone, and there's coins that are awarded. And to make the course self-paced, there's also this capture the flag event or Pi Wars that runs through days 1 through 5, where I present you with 90 different labs that you can work through at your own pace so that you can build your skills in Python. But let's jump right into the tools that I wanted to talk to you about. So this first tool I'm going to tell you about is all about finding evil through domain information registration. And this is really inspired by Justin Henderson and his talk in the SEC555 course, which is SANS SIM and Tactical Analysis course. And Justin talked about identifying domain, using registration information about domains to identify evil. And he really talked about the concept of baby domains and how malware, when we set up malware sets up command and control, they go out and they register these domains, and then they very quickly turn around and use them. So malware domains typically have a much younger domain registration than legitimate domains. So if we can use that information in looking through our logs, looking through our packets, we can identify probable malware on our network. The problem is that using whois to look up domain information is not easy. It's usually not very fast. It's actually very slow to look up domain information using whois. And if you want to do that at mass, where you're going to look at every single domain name that you see as it's flowing across your network in real time, well, whois doesn't really lend itself to that very well. Also, it's a command line based tool that doesn't give you back structured output. So ingesting that into a SIM like Logstash or ElkStack or any of those things, it's not very easy to do. There's not a very consumable, easy to consume or data structure given from that tool. So with that domain stats, the first tool I want to tell you about was born. And the purpose of domain stats was really to solve those two problems. One is to make all of that whois data readily accessible to you in a very fast and easy to consume method so that your SIMs can ingest that data and make it available to your analysts. It solves this by doing caching of records and prefetching domains. So when you start up the thing, it'll go out and it'll query the top 1,000 most commonly used domains, and it also comes with today a little database of whois records that for the top 1,000 domains. Now, the domain information may change, so the online information is date, but for things like, the creation date of Google has been around for a while, so that information doesn't change that rapidly. So how can we use this tool? First, is it effective? Well, let's use whois and actually look at the creation date for some commonly used domains. So here I'll go through and I'll ask, all right, for Google, all right, what is I'll use whois and I'll ask whois to go get the record for Google. Then I'll grep for the line that contains the word creation. Now you can see here the creation date for Google was 1997, YouTube 2005, Reddit 2005, Slack 1992, and the baby of the group was Snapchat 2012. So all of these domains have been around for 6 years or more. So they're older domains, right? The majority of these they're not brand new domains. So looking at these dates, now I'll go out, I went out to a repository of known command and control, known malicious domains, and then I did the same thing for those domains. So here I grabbed the first 5 known malicious domains I came across in the list, and I did the same thing for it. So for this domain here, 2017. This domain here, 2006. So that's not making a good case for me here, but I didn't want to cherry pick good answers for the presentation. These are legitimately the first 5 malware domains that I grabbed off of this particular list. So the fact that one of them in there is older doesn't help my case, but you can see that the majority of these here, 2017, 2018, 2018, very recent domains. The fact that this is 2006, actually the use of dates to figure out whether or not it's possibly malware is so effective that the fact that this has been around since 2006 makes me question that particular domain as to whether or not it was actually malware. I would want to do some more investigation into that. But in just picking it, you can see here that very recent domains is a good way of identifying malware that's traveling across your network. So if we could solve that problem of making this whois lookup accessible to our SIM products, such as Logstash, and Security Onion, and others, then this could be useful information to us in doing our analysis. Well, that's the purpose of domain stats. Now, to install domain stats, it does require that you use one non-standard Python module that's not part of every Python installation out there. You can do that by running this top command here, python -m pip install python whois. This will install the python whois module, which allows the Python script to talk to the whois servers. The other thing, excuse me. The other thing you're going to need is a copy of domain stats. You can get that with Git. So we use git clone, and we'll just clone my Git repository here, which will download domain stats to your machine. And then you change into the domain stats directory, and you start the tool. So here I'm using Python 2. I could run this with Python 3, which would make it a little bit faster for me. If I run Python, put the number 3 at the end there, run Python 3 domain stats, and then the command line options to domain stats. Now, the only required command line option for domain stats is this port number. You have to tell it what port you want the web server to be listening on when you access this, so that you can make this thing available to your SIM. And then you can start to query it. Let's not do this through slides. Let's actually try it in a demo here. So I'm going to cd into my domain stats directory, and then I'm going to say Python 3 run domain stats, and it comes back with my command line options. I can see the only required option is the port that I want to listen on, but it does have some various options, such as telling it how many domains I want it to go out and query in the background to pre-stage the cache of the web server with common domains. So I could give it an Alexa file. What I could do is I could say -a, and then give it an Alexa file such as top1m.csv, which is also distributed with it, and then tell it to -- preload the first 10 domains from the Alexa, which would go out, and after it runs this service, I'm going to start this up on port 9000 and tell it to be verbose so I can see what it's doing. And it goes out and it starts making whois queries to fill the cache on this machine with those first sets of things. So that way it will make it faster. Another way I could do this is I could just not provide that. And if you don't provide any options here, then it actually just preloads the top 1,000 most commonly used domains directly from a little file that's on the disk. Now, that file is going to be out of date, right? It's going to be based upon domain information from when I built the file, but that's okay if I'm looking for things like creation date. So now I can take a web browser, I can point it at my web server listening on port 9000, I can ask for domain, google.com, and it gives me the whois record that's associated with google.com very fast, and it gives it back to me in a JSON format here, so I can consume this with my SIM products. And if I ask for domain, it gives me the entire domain, but I can also add fields, specific fields in here that I want, such as the creation date. And now I just get back create date, creation date. Now I just get back the creation date. And I can continue to list fields such as state, let's see, zip code, and so forth. And I get back different pieces of data. I can come in here. I can also add emails, and I can just add the fields that I want or that I need for my SIM product here. And this keeps it all cached, and it's very fast for you, so that you can consume this and empower your analysts to find these baby domains and these malicious domains through creation date and other suspicious fields that are in their whois records. So domain stats, one tool that you can use to enhance your analysis of malware that's on the traffic that's going on your network. Another tool I want to talk to you about we need to first talk about DGAs, what DGAs are, and how attackers use them before we can find this tool to be useful. So imagine you're an attacker, right? You've got this big botnet that you control. If I registered all of my bots on my network to talk to me through my domain, mybotnet.com, so they're all talking back to mybotnet.com, and then law enforcement comes and they take down my botnet, or network defenders figure out that mybotnet.com is not probably some traffic that they want to see on their network, so they begin blocking mybotnet.com. Well, my domain goes away, and now I still have these hosts out here that are infected with my malware, but they can no longer talk to me at mybotnet.com. Well, as an attacker, I'd like to maintain control of those hosts forever. So what I'd like for them to do is to automatically come up with where I'm going next and then reconnect back to me. I'd like to purchase a new domain and have them start talking to me at my new domain. Well, when I come up with this new domain, what I'd like to do is I need the domain name to be something that's obscure enough such that it's not already owned. In other words, if my bots come up with the name, they come up with the next name that they're going to go to is google.com, well, I'm out of luck as an attacker because that domain is not available for me to go and purchase, and so I'm not going to be able to gain control of my bots. So I need the bots to come up with an obscure name, and I need them to have an infinite number of possibilities of different domains. So if defenders keep blocking my domain names, well, then I want it to constantly come up with a new one in a way that's predictable to me. So what bots have in them is what we refer to as domain generation algorithms, where they will choose these new domains in a way that is automated and is predictable to the attacker. And this is what DGAs are. Now, because they need to be available in an infinite number of possibilities, these domains often end up looking like random character strings, such as you see here in this domain. And you'll see these domain names in various places, such as in the SSL certificates that are used by malware, or DNS logs. You'll see them in your DNS logs, or actually in the HTTP requests that are going across your network. So there's lots of opportunities to find these malicious domain names, or these DGA domains. Well, I was sitting in SANS SEC573 Continuous Monitoring and Security Operations with Seth Meisner, and I was listening to Seth talk about how the techniques that were available at the time for finding these, and how most of them are rather complex because they're using artificial intelligence to analyze these. And one of the reasons that they're complex is because using standard tools that identify randomness just doesn't work for text, right? So if you think about it, all of our domain names are going to be lowercase letters and periods. So that's 26 letters plus 1 period. 27 possible letters are typically going to be in our domain names. And a byte of data stores up to 255 possibilities. So if you're analyzing a domain name like this, reddit.com, at the byte level, well, each of these is actually very predictable. It's going to be one of those 27 out of 255 possible characters that we have for a byte. So at the byte level, these aren't they're not random at all. They're all within the 26 or 27 possible characters. And the exact same thing is true when we start looking at these random characters out here. So when I take something like reddit.com and I run it through a traditional randomness tool like int, which measures the entropy of a file, the entropy of reddit.com and youtube.com turns out to be very similar to the entropy that you would find in these DGA domains. So traditional randomness doesn't work very well in identifying these, which means you're going to have to resort to artificial intelligence, machine learning, and these more complex systems, or a tool like Freq.py. So with this and listening to this, as Seth was lamenting the difficulty of this, I thought, I can solve this problem. And I did it through frequency analysis of characters, which we'll talk about here a little bit. And Freq.py and Freq server were born as a result. Now, Freq.py is a command line tool that lets you measure the randomness of these characters. And Freq server, much like domain stats, it takes that information and it makes it available to your SIM products so that you can take that information, consume it into your enterprise management platforms, and use that data to find evil in your network. So Freq and Freq server both give you reliable scores that you can use to identify these malicious DGO domains on your network. So let's talk a little bit about how they work. So this is the idea I came up with in 5.11. So what I said is, all right, I'm going to just analyze regular text and build a table of what regular text looks like. And I deal with character pairs. So let's say I'm analyzing the phrase bad banana. So I take the first character pair, which is a B followed by an A, and I build a table that says, all right, I have one B, and it was followed by one A. Then I go into the next character pair. All right, I have one A followed by one D, and I continue to build a table that says this character was followed by this character this number of times. I get to D space, and this is where I had to make a design decision. I think I made the wrong design decision in my first attempt at Freq.py when I was sitting in 5.11, but in my defense, I wrote the tool in about 30 minutes. So what I decided there was, there's never going to be a space in a domain name. So I'm going to allow you to pass this command line argument, ignore characters, and I'm going to ignore them. When I'm building my data structures here, I'm going to ignore those characters and not include them in the table. So that's the design decision my original Freq tool made, which is probably the version that most of you are using today. My newest update to Freq no longer does that. Today, it does analyze all of the characters and includes all the characters in my frequency table. Now, the reason I think that that's a better command decision is I still allow you to ignore characters, but I only ignore them in calculating the frequency value. So, in other words, I can have one table and randomly choose, or at will choose, which characters I want to ignore in the calculations, and I don't have to rebuild new tables every time I change my mind about what characters to ignore. So in today's version, I will add a D and a space to my frequency table, and then a space followed by B. I'll add that to my frequency table, and a B followed by an A. Now that's my second BA, so now I have two Bs followed by two As. And I continue to do this. So AN, I'll have two A's. It was followed by one N and one D. And I'll do this for the entire phrase. And with this frequency table, you can see that I can come up with some statistics about what normal text looks like when I analyze the phrase bad bananas. And with this, there's a 100% chance that if you have a B, it's going to be followed by an A. 100% chance. There's a 100% chance that if I have an N, it's going to be followed by an A. Now, if I have an A, there's a 50% chance it's going to be followed by a D, 25% chance it's followed by, A, 50% chance it's followed by an N, 25% chance that an A is followed by a D, and a 25% chance that an A is followed by an S. So I could use that and compare it to other words to see if these are normal based upon my frequency table. So I analyzed lots of text. I analyzed political speeches. I analyzed documentation for websites. I analyzed the complete works of Charles Dickens, and I came up with frequency tables that I can use to measure against English text to see if things are normal. And once I've got these big tables, I have two measures, two ways to calculate what normal text looks like. One of them is the average probability, and the other one is the word probability. Now, this first method is the one that was built into my original Freq.py, which is, again, probably the version that most of you are using. And it's very effective, but I think there's a better way, and that's this method 2 that I'm going to talk to you about today. All right, so let's talk about how I could measure to see if a phrase is normal now. So let's take the word queen. I want to see if queen is a normal word. So I've got my big, huge frequency table where I analyze lots of text and have lots of numbers in there. And just for your reference, all of the numbers in here are made up. These aren't actual numbers from frequency tables. So, but these are just samples of data that are in here. So in measuring the word queen, I'm going to take my first character pair here, QU, and I'm going to go look at the numbers that I have in there. And I say, okay, Q, 462 of those followed by 440 U's. So 95% of the time, the letter U followed the letter Q. That's in normal English text. It's actually more like 98% of the time. If you have a Q, a U is going to follow that. So that's a very high character probability. Then I'll take UE. I'll go into my frequency table and I'll say, okay, I had 3,000 U's followed by 1,000 E's. That's a 32% chance. Excuse me. And then I'll continue that for all of the words, and I'll come up with all of my probabilities, and then I'll average the probabilities. So in this case, you can put your calculators down. These are all made-up numbers, just to give you an example, an idea of what I'm doing here. I average those probabilities together, and I'd say, okay, Queen is 42% probable. So that's a very likely going to be normal text. And if I take a random set of strings, such as we would see in these DGA domains, and I do the same thing, well, E followed by B is pretty improbable. B followed by U is, maybe a 5% chance. U followed by U is improbable, and U followed by Q is improbable. So its average probability comes out to be much, much lower, 2.8% of these. So this technique turned out to be pretty good for identifying these random characters that we have inside of these DGA-based domains. And using this, it's been integrated into several platforms. We'll talk about those in the future. But I think that there's a better way, and that's this new method that I've introduced in the most recent version of Freq. That's method 2. Now, what I do with method 2 here is I'll take Q followed by U, and then I'll just total the number of first characters and second characters. So I had 642 Qs followed by 440 Us. And then I'll take UE, and I'll say, okay, now I had 3,462 first characters followed by 1,112 second characters. And I'll just total up all of the first characters followed by the second characters. And I will then add 462 plus 362 plus this comes up with my total for the first characters. I'll add these numbers. I'll come up with the total for the second characters. And then I will take that as a probability and call that my word probability. And I believe that this is going to actually give me better measurements in finding these frequency table, malicious DGA domains. Okay? So let's look at the results. Let's see what happens when I put these some legitimate domains and malicious domains through Freq. So here I'll use Freq.py. The way that you use the command line version of this is say Python Freq.py -m for measure the probability of the following word. I want you to measure the probability of google.com, and then you give it a frequency table. Now, I provide you with a frequency table with the tool, and you can just download that and use it to measure probabilities. And here you can see the new version of this tool gives you back two numbers. Here's method 1's result, and here is method 2's result. And you can see that all of my method 1 results are more than 5. So normal text, such as Google, YouTube, Reddit, Slack, Instagram, greater than 5 for method 1. For method 2, it's all of these numbers are greater than 4, right? So they're all more than 4 for method 2 in measuring these measuring legitimate text. All right, so what does illegitimate text look like? Let's use those same domains that we looked at earlier with domain stats. I'll take those same domains and I'll put those through frequency.py, and you can see that that method 1, all of these numbers are less than 5. So 5 seems to be the magic number for method 1 in identifying malicious code, but obviously the lower the number, right, that you have coming out of Freq.py, the more random or the more unusual it believes that the text is. Now for method 2 in Freq.py, you'll see that all of my numbers here are significantly less than 4. So method 2, this new method of giving it, or my word probability, as opposed to the average probability number, seems to be giving me a much more reliable way of identifying these. And I believe that method 2 is better than method 1 for several reasons. One of them is that method 1 could be thrown off with a single QU pair. So with method 1, Q followed by U, 98% chance that that's going to happen in normal English. So when I average 98% plus 0.1% plus 0.1% plus 0.1%, that still comes up to be a big number. So here, if I take this this known malicious domain here, and I run it through Freq.py, you can see that method 1 had a number that was less than 5. But as soon as I change the letter B to a U, and I now have a QU pair, you can see that my method 1 number was thrown off, and that would no longer be identified as random characters. It's above that 5 threshold. Whereas method 2 is much more tolerant of a QU being added to those values, because it's based upon those probabilities, and it's based upon the word, the weighting of those words. So where letters like R, S, T, L, N, and E, which appear much more commonly in language, those are going to have much higher numbers in my table, which means that the more commonly a word appears, those are going to be weighted better in my table. So this is a better measure of what normal text looks like. Okay? Here's just another example where I take just a domain that was easily identified as malware by both method 1 and method 2. By just adding a Q to the front of that piece of malware, I now have method 1 is being thrown off by 8. So I hope I've sold you that method 2 is a better way of identifying malware domains that are on the network, which is available in the latest version of Freq.py. Okay, so that's Freq.py. How do we use it? Well, it has no dependencies. You can just git clone install, git clone my repository, change into that directory, and then use either Python 2 or Python 3 to start the frequency server. Let's actually go ahead and run the tool in demo mode here instead of looking at the slide. I'll clear my screen. Let's see here. Get out of my tool. Control L, clear my screen. All right, so I'm going to change into my frequency directory here. cd ... cd freq.py. And when you clone the directory, you get a couple of different things. You'll get Freq.py, which is a command line tool. You'll get Freq server, which will serve up that information so that it's available to your SIMs. And then you get a frequency table. So I can just say Python, Python 3 or Python 2. Let's just use Freq.py and measure the randomness in the string bing.com. And I have to give it a frequency table. So I'll say Freq table 2018.freq. And it measures my frequency of bing.com, and it gives me a 10 and a 13. So well above 5 for bing.com. And then I'll come in here and I'll just type monkeys banging on my keyboard .com. And you can see that here the numbers are much lower for these for that particular string that's in there. Now you'll notice that my second character here is above 4, and I will guess that that is because of this ER in there. So yeah, so you can see that even though this new method is less susceptible to bypass by characters, it's still, the more your words look like normal English words, then the higher the numbers are going to be for that number. So if the more normal the characters look, this is just a measure of these things. So you can see in some cases method 1 did better, in some cases method 2 did better. Now to make these things consumable by your SIM product, then you just run Freq server. So I'm going to run Freq server. Freq server requires 2 arguments. It's going to require a port you're going to listen on, and the Freq table. So we'll give it Freq table 2018.freq. Starts up my frequency table, and now I can come in here and I can tell it to measure /bing.com, and it comes back with my frequency table. Now it gives me both of these numbers. If you want one number or the other, I can come in here, I can say measure 1, and I get just measurement 1. I can say measure 2, and I get just measurement 2. So these numbers are given back to you in a way that's easily consumable by your sim. You can either take both numbers, one number or the other, and integrate them into your sim scoring. Now, and you'll notice in this case, I'm using Freq server, which is the frequency table that I have distributed with the tool. So I'm using freq.table.freq. This is based upon the analysis of English text and speeches and things like that, which might not be the best possible scores for your domain. That's the beauty of Freq command line tool, is that you can use Freq.py to adjust these frequency tables. You can create new tables with -C. You can measure normal files, right? So you can do -N and you can tell it something that's normal, or you can do -F and give it a file that's filled with domain names that are normal for your organization, and this will build these frequency tables. So for example, if I want to build a new frequency table, I'll say build a new one called marktest.freq. That created a frequency table. And then I'm going to say, hey, normal text for marktest.freq is the string Mark was here. And I got to give it my frequency table, so marktest.freq. So that just told it Mark was here is normal text, or I could give it -F and give it a file that contains all the domains that I normally see. And now I can use Mark test to now measure what's normal for my domain. So I can say measure Mark using Mark test, and it'll say, oh yeah, that's pretty probable according to this frequency table. But when I want to measure something like this, yeah, that's not going to happen. So you can see here what's normal is much more pronounced with your own frequency tables that are normal for your organization. So you can build your own frequency tables. Okay, so that's Freq.py. Here's a look at the interfaces. You can see you can use measure 1, integrate this information into your sim, and then you can use that to identify malicious hosts. As I showed you, you can use the command line version of frequency to build your own frequency tables. You can also use this to adjust the frequency tables for your particular organization. So I think using my frequency tables that are distributed with this thing, let's just measure CIA.gov. Let's measure CIA.gov, which turns out to be a pretty unlikely set of characters according to normal English characters. So I might want to say, hey, you know what? That's normal for this, and the weight of that is 100. Right? So that will add 100 occurrences of CIA characters to my frequency tables, which will change the information that's inside those tables. So the next time I go back and measure it, I can change those probabilities. So here you can see that my probabilities changed for CIA.gov, and I could continue to adjust those numbers so that domains that stand out that are not normal become normal inside of your frequency tables. So the command line version of that is very useful, and you can use this to build frequency tables for your own domain. Now, this is already integrated into SIMs that are out there, such as Security Onion. So when you're in Security Onion, you'll notice a little tab down there that'll show you frequency scores for domains that are on your network. This is talking to freqserver.py. It's part of the Security Onion platform, and you can see here where it's giving us measures of different domains that I'm seeing on the network. So you want a quick and easy way to integrate this and to get these frequency scores, I would encourage you to download the Security Onion. It's a great platform for analyzing traffic on your network and finding malicious traffic on your network. The third tool I want to mention to you very quickly, because I'm going to get to some questions and answers, so I'll take 10 minutes to talk to you about finding evil on your network in Windows Task History. So on Windows 10, Windows 7 and later, if you go to your Task Manager, you notice that you have this App History tab, and usually if you go in there, you'll see a bunch of statistics about Metro apps that are on there. They'll tell you how much CPU time, how much data has been on the network, and some other information that's on this that is collected, Windows collected about these apps running on your machine. Well, I was sitting in SANS Forensics 500 listening to Ovi Carroll, who's Ovi's awesome. If you ever have a chance to listen to Ovi, I was listening to Ovi talk about all the data actually stored in this app history database that's not displayed by the graphical user interface. All this information is kept in what's called the SRUM, or System Resource Utilization Management database that's on your system. But at the time, most of the tools that were available to analyze the SRUM were either very expensive or just not easy to use. And so Shrum Dump was born. So Shrum Dump will analyze the SRUM database on your system and create Excel spreadsheets or CSV files that'll show you what processes are running in your system. So consider this situation. An attacker breaks into, or is perhaps sitting at, an administrator's machine on your laptop. And while they're there, they create a directory called tools. They then use a hacker account that they created on their system. So they create a new account called hacker. They use that hacker account to connect to a nearby wireless network so that they bypass your firewall and IDS. And then they use FTP to download some hacker tools from a remote website over that wireless connection. And they store that in /tools in tools.zip. They unzip it. They run a backdoor called backdoor.exe. They compress some data up. They transfer it out over the wireless network, and then they delete all their files, all their accounts, all the stolen data, the directory. Of course, once their user account is deleted, the profile that's associated with it and the wireless connection and all that stuff just is gone on the machine. So how long would it take you from an incident response standpoint to figure out what's going on? Typically that means doing some very extensive forensics to look at deleted files, to look at deleted accounts, to identify what's happened on that system. Well, all this information is easily retrieved by looking at that System Resource Utilization Management database. So what Shrum Dump does is it takes in 3 files. Well, technically 2 files and 1 optional file. And then it creates an output file. Now there's different versions of Shrum Dump. I've got a shrumdump.exe, which is an executable that creates an Excel spreadsheet. Now, if you don't trust executables that you download from the internet that have been written by Mark Baggett, I would say, well done, smart move, right? If you prefer, you can run my Python script, right? And just you can look at the code itself. If you don't know what, if you can't look at the Python code and identify whether or not it's evil, come to my class. I'll teach you how to recognize good versus bad Python code. So I've got shrumdump.exe and shrumdump.py. Both of these create an Excel spreadsheet as an output. Now, some Shrum databases are so large that I found that my Excel engine library that I was depending upon inside of Shrum Dump was dying for very large Excel spreadsheets. So there's a shrumdump.csv, shrumdump.csv.exe and .py, and these will produce CSV files. And I find that the second version to be a little bit more reliable than the first version. So the tool is going to need a copy of shrumdb.dat, which is typically in your C:\\Windows System 32 SRU folder. And this file is locked by the operating system. When I get questions about Shrum Dump, the most common failure that people have in trying to use the tool is that they tried to grab a copy of Shrum Dump while the system was still running, and they got a corrupted copy of Shrum Dump or srudb.dat. So you need to use a tool such as fget or some other forensics tool that will let you get files that are locked by the operating system, or take the file from a forensics image from a backup of the hard drive. But make sure you get a good copy of srudb.dat. You also need a template. The template, which I give you one with the tool in my GitHub. This contains a list of all the fields that you want to extract from the database. Now, by default, the template that you get extracts everything. And it's perfectly fine to use this template, but if you find that it's extracting too much, you just want to focus on particular fields, you can edit this spreadsheet and select which fields you want to extract and how you want them displayed in your spreadsheet. And Shrum Dump will look at how you've specified that information in this template in determining how it's going to create the output file. The last file you need is, and this is optional, would be a copy of the software registry hive on the same system. If you provide a copy of the software registry hive, then it'll do things like look up user SIDs and tell you which user account is associated with it. It'll look up wireless connections, and it'll give you actually the SSID name of the wireless connection that was being used in the attack. But if you don't provide this, you'll still get some information. It's just not as easily digestible or human readable from the system. So we grab these files, we give it to Shrum Dump, and then we analyze our output file. Here's just an example of an output file from a Shrum Dump database. You can see that it has multiple tabs here across the bottom in the Excel version. In the CSV version, we get several different CSV files, one for each of these tabs. But if I just look at like the network usage tab, you can see here that it's got a date and time that's associated with this. It's got a full path and the name of the executable that was run. And this will record every executable that's run on your machine in the last 30 days. So if you've ever been sitting there and like something pops up on your computer and you're like, oh, what was that came up? I really wish I knew what that pop-up window was. You can't go to Task Manager because, well, the process is gone. But it is kept inside of that Shrum database. So you can go back and you can look and see what processes have run. So here we got the name and the full path of the process. We've got the user SID, and if you gave it the software, it'll translate this into the account name for the person that did it. If they were connected to a whatever network they were connected to, it'll tell you that, and it will translate that into a profile name or in this case, a wireless network name if you give it the software database. And I can see how much data was transmitted across that network. So back to our scenario that we had earlier, that hacker account, the account that was created and deleted, I have the SSID for that account here. That tools directory that was created and deleted, I have the name, the full path of that directory and the names of the tools. The information that was transferred across that wireless network, I've got the wireless network and the size of the files, the amount of data that was transmitted across that. So lots of useful information that's incredibly useful to us as incident responders without having to do a lot of extensive forensics are available to us inside of this Shrum Dump.
Hey, Mark,
now,
real
what
quick.
do you need?
If application usage history is deleted by a user, does the Shrum database get wiped out as well?
If application usage, oh yes. So if you're in the task manager here and you come up and you say delete usage history, this is deleting that Shrum database. Yeah. So if this is clicked and they delete that app history, it is going to delete the information out of that Shrum database as well. Yeah. Excellent question. Thank you for the question. All right. So in my 1 minute I have left, how do you get a copy of this? Well, you can clone my entire GitHub, or you can just grab a copy of my Shrum Dump executable and my template, and you've got everything that you need. I also provide in my template a copy of HP Gary's fget, which you can use to grab files that are locked by the file system. The only reason these are HP Gary's tools. The only reason I included them in there is because, well, I like them, and it's difficult to find them. Actually, you can usually only find them on some pretty sketchy looking websites out there. And that's it. So what if these three tools that I've talked about today don't do exactly what you need? Well, let me know. Tell me, hey, I'd really love to see that tool do this thing for me. It would be perfect for my needs. I'm happy to support these. Or a better option would be to come check out 573. 573, I'll teach you how to customize web apps. Not just my tools here, but any Python tool that you come across. You're like, yeah, this does most of what I need, but I really wish it would do this for me. I'll teach you how to customize that tool and get you to make that tool do exactly what you need to serve what your organization needs, as well as create brand new tools to solve lots of new challenges that we find in information security. That, let's face it, the tool industry just doesn't know exactly what your organization needs and can't keep up with the rapid changes. You need the ability to create your own custom tools within your organization. And with that, I will be happy to answer any questions that you have regarding 573 or these three tools.
Mark, I got some questions coming in now, so I'm going to go through. But the first question was, what is the recommended study material to prepare for 573?
Yeah, so you don't have to know anything. I mean, I assume you know nothing coming into the class, and we will have that essentials workshop, but the class is self-paced, and the more you know, the more you get out of the class. So if you already come to the class knowing some Python or knowing completely how to code in Python, then you're going to get more out of the class than someone who doesn't, right? If you came in at 0, I'm going to try and get you to 3 or 4. If you came in at 5, I'm going to try and get you up to 9 or 10. So whatever you come in with, I'm going to meet you there and move forward. Now, I would highly encourage, there's lots of free Python classes out there, like Code Academy has got awesome Python course that such that you'll understand how to build a Python function, what a variable is, if then else. If you understand that material when you come into the course, you're going to get much more out of it than someone who's brand new to never coded before. For those people that when they leave there, if you've never coded before, I hope to get you to a point where you can read Python code and understand what's going on and make simple modifications to that course, and as well as prepare you for the GPYC certification that is associated with the course.
Awesome. Thanks, Mark. Next question from James. Do you find Freq.py to be useful in threat hunting scenario, or do you think the CM integration and Freq server is required?
Certainly Freq.py is, you can give it some text, right? I can give it a domain. So the command line version of this, you in your threat hunting scenario, you would already have to have identified the malware domain, and it's probably already going to stand out to you as a threat hunter. If I see a domain that's like xyz123.biz, my radar is already up, and I don't need Freq.py to tell me as a threat hunter that, hey, that's unusual. So really, I think the power of Freq.py is in the automated analysis of large quantities of data, right? So that I don't have to fish through terabytes of PCAP files and log files to look for these unusual domains, that it's going to find them for me and raise that flag. I see it more as an analysis tool than necessarily an individual threat hunter looking through things on their own. And when I think of threat hunters, certainly there's some tools that you can use to automate processes like that, and integrating in Freq.py to those systems could provide some benefits. But usually my threat hunting process is a much more manual process of looking at hosts, looking at the logs that are on those hosts, and in doing so, I'm going to use some Python tools to do that, where I could see some benefit of bringing in Freq.py.
Okay.
I hope that answered that question.
What was the tool you mentioned to get a copy of Shrum?
To get a copy of Shrum?
Yes.
I mentioned HP Gary's fget, which is in my GitHub. You'll see a tool called fget. It's by HP Gary, and it just will allow you to grab a copy of a file that's locked by the operating system.
Mark, from Joseph, are scrapers covered in class?
By that, I assume you mean web page scrapers. So we will talk about using the requests module to interact with websites. And of course, with that, you get all of the HTML that's associated with that. When you say scraper, I typically think I'm not interested in the HTML. I am interested in the text itself, which is not inside of those HTML tags. And we'll talk about a library called Beautiful Soup. And there is another module out there called Scrapey, not Scapey, which I know many of us are familiar with, but there's a module called Scrapey, which is focused on extracting that text. So we talk about those, but we don't actually write a scraper in there. But I will teach you how to interact with websites and how to use modules such as Scrapey in order to write your own scrapers.
Mark, there was a follow-up talking about pastebin, so scraping pastebin.
Okay. Yeah, so Pastebin scraping is actually pretty easy because it's already in text. So just using the requests module to interact with that website and to constantly pull that information, certainly the concepts of everything you need to do to be able to do that are covered in the course. Excuse me.
From Dave, does Freq.py take into account other languages than English?
So Freq.py itself is language agnostic. Now, my frequency table that I provide to you in my GitHub is based upon English text. But I give you a copy of Freq.py, and as you saw in the slides there, it's pretty simple to create your own frequency tables. So Freq create some new frequency table, and then use -n for normal or -f to give it files that are filled with other languages. And you can build frequency tables that are based upon whatever language that you are looking at. But Freq.py is based upon normal English text. If you take the time to build a frequency table based upon another language, I would be very appreciative if you'd share that with me, and I can share it with the world in my GitHub.
And then Mark, we just have some comments coming in saying, great presentation. Thank you very much. People are using the tools, looking forward to using the tools. Glad that it's integrated in Security Onion. So things like that, people are excited to start using the tools. I have one last question for the course because I don't see any other questions from others. Is the course essentially just for pen testers or forensic people or cyber defenders? Is there a specific person who should take the course?
Yes, everyone in the world should take the course. No, the course is not targeted at one particular. As a matter of fact, after the Essentials workshop, there is a day that is focused specifically on projects that would be common to defenders. There's a day that's focused on projects that are common to forensics analysts, and a day that is specific to projects that are common to pen testers. So while there's days with those projects, the course itself isn't targeting one particular focus or another. So in the defensive day, for example, we'll teach you how to read files, how to do regular expressions to extract useful files. On forensics day, we're talking about how to analyze binary data and how to find useful artifacts in memory inside of executables, inside of packets, and things like that. And on the offensive day, we talk about network-based communications, all concepts that are useful to you in information security, regardless of your discipline. But I do give you themes for these different days to get your mind thinking about how to apply these concepts in each of the different fields.
Thank you, Mark. I had one question where someone asked, is going to be available on VLive? The answer is not at this time, but it is available in on demand, and people can get 4 months of access to the content there. Mark, we are running out of time. Since we're running out of time, do you have any final words?
Yep. If you're VLive, no, but we do have simulcast, right? So we got simulcast coming up for SANSFire and network security. So if you can't attend directly, you could simulcast into those classes. And of course, on demand is better. If you've never coded before, I actually think that the on demand is a better platform because you have 4 months of access to the video lecture, and there's an additional day's worth of recorded material in the on demand that walks you through every single one of the capture the flag challenges, which I typically don't explain in the live class.
All right, and Debbie, I'm going to turn it over to you to finish. Thank you, everyone, for tuning in today.
Thank you so much, Jason, and thank you so much, Mark, for your great presentation. To our audience, we greatly appreciate your listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. You can find your CEUs for all completed webcasts by logging into your SANS portal account. Navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the webpage. Until next time, take care, and we hope to have you back again for the next SANS webcast.